Hi Dipshika, hi Avita. We are live on the channel, so let's get started.
Okay. Okay, fine. So, a very warm good afternoon to all of you, honorable speakers and members of AWS, esteemed UPS faculty members and attendees. I would like to extend a warm welcome to the webinar Empowering Young Minds About Cloud Computing with AWS, that is powered by AWS Educate in association with UPES Cloud Security Alliance, Student Chapter and Department of Virtualization, School of Computer Sciences. I would like to take this opportunity to introduce our guest speakers, Ms. Rohini Gaonkar, Senior Developer Advocate AWS, and Mr. Suman Debnath, Principal Developer Advocate AWS, who would be our guest speakers today and would impart their knowledge focusing on the use of innovation-centric technologies such as AWS to solve today's pressing needs. As you all know, cloud computing is not only the future of computing, but the present and the entire past, undoubtedly one of the most radical and transformative inventions in today's world of technology. To establish and endorse the use of cloud computing around us, University of Petroleum and Energy Studies Cloud Security Alliance embarked upon its glorious journey as the first ever cloud and security centric student chapter in UPS in the year 2017. And since then, it has strived to empower its members with knowledge. I would like to take this opportunity to request Dr. Deepshika Bhargav, Head of the Department of Virtualization, School of Computer Sciences, to say a few words on this occasion. Ma'am, please, over to you.
Thank you so much, Avita. It is really a proud privilege for all the students of UPES, and it's really great to know that UPS CSA student chapter is indeed an active chapter, and I've seen they are coming forward with new ideas and different kind of activities, and this is lovely to be here. On behalf of University of Petroleum and Energy Studies, I would like to thank Ms. Rohini and Mr. Suman for taking out time from their busy schedule and here with all the students to have their sessions on AWS, and specifically very close to my heart is deep learning. So thank you so much, everybody. And definitely, I could see the name, the registered students and their number. It's really very encouraging that 400 plus participants have been registered for this session. And definitely, you are going to learn a lot. And wish you all the best. Thank you so much, Avita. Thanks once again.
Thank you, ma'am. Talking about our first guest speaker, Ms. Rohini Gaonkar. She brings over a decade of experience in IT industry, primarily focusing on cloud computing technologies. With AWS since January 2014, she has worked on multiple roles, including being a solution architect in Asian and India. As a solution architect, she has focused on the needs of cloud native customers and is actively involved in the DevOps and container space. She has been leading conversations with business of all industries and sizes on innovation as they deploy critical workloads on the cloud. Also, we are joined with Mr. Suman Debnath, and he is a principal developer advocate at AWS. He tries to simplify the intricacies of AWS cloud services to developers, aids them to unravel its optimum possibilities and obtain its utmost usage into their application. His key focus are the areas of machine learning, data analytics, and storage. So with this brief introduction, I would like to request Ms. Rohini to continue the session from here. Ma'am, please.
Hello, hi. Thank you for that introduction, Avita. Let me just quickly share my screen.
Rohini, ma'am, your voice is breaking. Can it be a bit loud?
Um, just- You hello. Okay. And I think we are there. Cool. So thank you for joining this session, everyone. It's amazing to talk again with the student community. My name is Rohini. I have, as Avtam mentioned, I've been with AWS for last 6+ years. I've done multiple roles in AWS, primarily as a solution architect. Right now, I'm a developer advocate. Uh, Also, you can reach out to me via Twitter, via LinkedIn. If you have any questions, feel free to ask these questions. And I truly believe no question is dumb. So if you have any question, please feel free to reach out. Also, I have recently, like just last month, I've started my own YouTube channel. So if you think you have some questions about training, about certifications, I have made like 2 videos with some of the experts from AWS. So please, after this event is done, not now, please go ahead and subscribe to my YouTube channel and do watch some of these videos. I'm hoping these help the wider audience, have a successful career in cloud computing. With that, let's talk a bit briefly about the agenda. I know the agenda is a bit packed. I will try to make it simple, easy to digest kind of content, so that if you have been studying about cloud computing, or if you've been doing some projects around that, I'm hoping, or if you're doing some certifications, I am hoping that it helps you in the it helps you in the long term. So what is cloud computing? I think most of you know that, but just to set the definition for anyone who doesn't know what is cloud computing, is cloud computing by definition refers to the on demand delivery of IT resources and applications via the internet with a pay as you go pricing. So there are few things that you need to remember here. First thing is on demand. That is, whenever I want a machine, I should be machine or a storage or database or any kind of IT resource that I need, or any kind of application that I need, it's accessible to me on demand. That I want it now, I should have access to it right now. It's via internet, so you don't really have to go to a data center, don't have to go to any location to get access to it. So it should be over the internet, sitting at home, getting access to those resources. And last but not the least is pay as you go pricing. Uh, if I have to explain this to my mother, pay as you go pricing, it's as simple as how we pay for electricity, right? You switch on a button, the meter starts, and you start paying for the charges that are occurred for, for the metrics you're using the electricity for. And you switch off the button, you stop paying for it. As simple as that. So that is what is cloud computing. So AWS definitely provides broad broad and a deep platform that helps our customers, AWS customers, build sophisticated, scalable, and secure applications. Okay. So why do customers choose AWS? And this is something that we tell a lot of customers, but you are students, or you are in careers that you want to work with a lot of these customers on the AWS technology, right? So you need to know what are the factors that makes AWS a choice for a lot of customers. The first is the agility. So it allows a lot of our customers to experiment and innovate very quickly and frequently. What we mean is that if a customer needs cloud is virtually unlimited, what we mean is, like, if they need certain like say 10 or hundreds of virtual machines, they can request for those virtual machines, and within minutes these machines are allocated for them. Or if they don't need it, they've experimented, they've played with it, done their proof of concept, and they think, oh, we don't need this anymore, and so they can actually terminate it, or and stop paying for that kind of capacity. So with that pay as you go pricing, your customers can do a lot of cost savings, right? So when before cloud computing, most of the customers had to build their own data centers, they had to buy physical space, do a lot of insulation, because the server rooms are very must be very cold, because servers tend to heat up a lot and they need a lot of cooling, a lot of installation to be done. You need to have security sitting outside. So there's a lot of things that came in with just wanting to do some kind of application. And when cloud computing came on board, uh, the cost came down because now customers don't have to do all that undifferentiated heavy lifting. They can only have an idea, okay, this is my app, this is what I want, and they can just start doing that, right? Without having to spend a lot upfront. Okay, they will pay the bill later, but then they are paying the bill for only what resources they have consumed. The next part is elasticity. As I mentioned, like, initially when you had to have your own data centers, you had to actually understand, oh, how much machines am I going to need? Simple as how we did with desktops, right? Early on, oh, I need to do this kind of project. Maybe a simple home desktop, I need a smaller capacity. But let's say you're someone who wanted to go into machine learning or deep learning, and now you need bigger machines to experiment on. That kind of guessing had to be done beforehand, because that machine to be delivered to you assembled, that takes a while, right? And think of this at a enterprise scale, at a big company scale. It would take months to actually do that capacity planning, for them to actually procure something, for it to be delivered and then set up. It took a lot of time. With cloud, that is all gone now. Now you can have those decisions within minutes, and you can, if your application is like a game that just went viral, and you wanted to add more capacity so that that game can be served with best customer experience, you can just do that within minutes, rather than you just waiting years for that, right? And if the application just the whole buzz just dies down, and no one wants to play that application, only few people want to play that application, you can just easily shut down those machines without worrying about, oh, what will I do with these servers that I've procured, right? uh, Definitely this helps businesses innovate faster, go global in minutes. Now everything's over internet, right? You don't have to worry about traveling someplace to go to a data center. Now if I'm sitting in India, and my application is something very tuned to, let's say, a European market or an American market, I can still do that business sitting here in India, because now it's over the internet. And AWS does provide that kind of infrastructure. And definitely service breadth and depth, we'll look at this in more details. So because you're going to go and work with a lot of customers, or you're going to create a lot of create a lot of projects that will be used by a lot of customers, so you need to know what is a typical customer journey when they come to cloud. So when they come to cloud, they come essentially come with some kind of a project. Okay, so it could be a project for them to see, oh, does cloud make sense to us? Okay, let's do a sample proof of concept, or this is one of my low hanging fruits. If you can just show it that it works in the cloud, I'll be happy, to consider maybe moving to cloud. And this is how generally everyone starts with the cloud. Pick a project, something that you're interested in, experiment with it, play with it, break some things in there. Always you will learn something out of it. Like out of every failure, you will definitely learn something out of it. So everyone almost starts at the project phase. After that, a lot of customers feel, oh, now we have got a project, it seems good, we like this idea. Now let's say that anything new, or any foundational services or applications we have to build, will move it to the cloud, and they move to the cloud to build their foundation on the cloud itself. Then a lot of customers are like, oh, we had something on premise, we had our own data centers, it's going to be decommissioned because we have it's been 5 years or something, or the leases are running over, or some reason for decommissioning. They want to migrate to the cloud because now they want to innovate, they want to move to the cloud. So they do a lot of migrations to the cloud. Then a lot of customers do modernization, where just doing a lift and shift, like you had a 3-tier application or a monolithic application on premise, and you just move that to the cloud, it's not going to give you all the benefits of cloud. Cloud is meant to be used in a different way than how you were just thinking about doing your applications in data center. So a lot of customers do modernization to actually reap the benefits of a cloud application, right? And then there is always continuous reinvention that happens when they move to the cloud, and they keep reinventing the application, or there's a lot of innovation that happens. uh, we do have customers, not just startups, but we do have customers in enterprise segments, in public sector, or government related applications. There are a lot of software vendors that build their applications on AWS, and there are also system integrators. So these are some service industries where they are helping enterprise customers move to the cloud or do the modernization of the application or the migration of the application. So there are a lot of different range of customers who actually work with cloud itself. uh, Cloud does have an expansive ecosystem of partner network. So there is a lot of like companies like Capgemini, Infosys. They all have they are like consulting partners for AWS, and they help customers migrate or modernize on cloud. There is also AWS marketplace. So not AWS can create everything, right? Not like we cannot be creating all kind of applications, and the platform is quite free, or it's more like flexible, that whatever you want that makes sense for you as in the customer makes sense, and they want to use that on the AWS cloud, they can definitely look for it in the AWS marketplace. So, for an example, an antivirus solution, right? The AWS doesn't have an antivirus solution, but you think your application needs an antivirus solution, you can always go ahead and check it out on the marketplace, and with one click deployment, you can have it deployed on the AWS cloud. Quickly, we'll look at AWS Global Infrastructure. Okay, so initially, when AWS started our regions started in 4 regions across the world, and this is interesting because this is going to show you the how from 2006 till date how fast the adoption of cloud was, how fast the pace of innovation was, and how fast we actually released so many services. So first 5 years, 4 regions. Second 5 years, we had 7 more regions that we launched. And since 2016, there are like 13 plus regions that we have launched, and we have already announced 3 more regions across the world. Okay, so that's a lot of regions across the world. We have something called as regions, and then there is something called as availability zones. Okay, we'll discuss that in the next slide. But just to give you a bit more insight, in Mumbai, the closest for us in India is the Mumbai region, and Mumbai has 3 availability zones inside it. Interestingly, this is something new, and I would give this as a stretch learning for you outside of this session. Go ahead and read something around local regions and local availability zones. It's quite interesting. It's something that AWS has launched very recently, and it's a different kind of a perspective to how we are thinking about regions and availability zones. So go ahead and read about local regions and local availability zones. Okay. So what is region and availability zone? So a region would be combination of 2 or more availability zones. So let's talk about availability zones, and then we'll go back to regions. Okay. So an availability zone can be one or more clusters of data centers. It doesn't necessarily mean an availability zone is just one data center. Okay. So it can be one or more clusters of data centers that form an availability zone. And 2 availability zones will form a AWS region. And the reason we do this, and this kind of question comes in your solution architect exam, certificate exam, or multi-AZ is a very basic understanding of how AWS works, right? Why do we do this? So think of a point that there is 2 availability zones, and there is redundant internet, there is redundant power supply, and these both are a bit far away from each other. So if your application is hosted half year, what I mean is you can keep 2 virtual machines here, for example, 2 virtual machines here and 2 virtual machines here. And for some reason, this data center or this availability zone has some issue. And this availability zone is is failing, or something has gone wrong with the power network, and it's going to take a while for it to come up. Your application is still going to run from the second availability zone. It may run in a bit of a degraded manner because you may have to start more virtual machines here to take care of the customer load, but your application is still up and running, right? So it gives you a better customer experience to your customers, right? So building applications in a multi-availability zone kind of a way is something that we recommend to a lot of our customers. Okay. So with all that, we also have something called as CloudFront, which is a content delivery network, and we have a lot of points of presence across the world. Think about CloudFront as simple as, I mean, uh, as simple as you have. Uh, Sorry, I've just lost that. Think about CloudFront as simple as you have. A lot of points of presence across the world, and you have your application is used by a lot of people in India, but then some people, like there are NRIs who are sitting in US, also want access to the same application. Now, because most of your users are sitting in India, you would host your you would host your images, your application content here in the Mumbai region. And there are a lot of customers who are sitting in US, and they are also accessing the files. Now think about internet latencies when they are trying to access the files from Mumbai while they're sitting in US. Now every time they need a file, they have to go to Mumbai and come back. Internet latencies is something that plays a huge part in applications, right? So that way, if you see that the application response for US customers will be slow. So what happens in this case is, if you have a layer of CDN in front of you, and this is a very generic explanation that I'm giving. CDNs do a lot more than what I'm explaining, but as a layman's term understanding, what CDNs will do is, okay, it will pick up that file. If first time someone accesses it, it will pick up from Mumbai, and it will store in some edge location that is closer to the end customer. So, for example, it may store it on the one of the coasts for US. And the next time someone asks for the same file, instead of going back all the way to Mumbai, it will just serve it from its local cache. This way, it is improving the latency of your application and a better customer experience. Similarly, we have something called as direct connects. We don't have to worry about direct connects, but it is for customers who want a direct line to the one of the regions of AWS. Okay, and there are reasons why customers would need that, and we also have that kind of facilities. Remember, we talked about internet. Some customers do want a direct line. This is for those kind of customers. So quickly, what are the different products and services you can see from AWS? Don't be scared. There are a lot of products and services AWS has, right? And they are like what, 175 plus products and services that AWS has. You don't have to know everything. You have to know, or you as a student or you as a customer has to know what are the things that you would need for your application. Okay, so how we tell customers is, think of this as a Lego blocks, and you pick and choose whatever blocks you need for particular project or particular use case that you are trying to solve. You may not need all of them, you may need some of them, but how do you navigate through this whole plethora, right? First and foremost, if you can see my mouse, you have to know the infrastructure. If you have to know the regions, availability zones, and points of presence, you have to understand, acha, what is the base that makes AWS, right? So we just talked about infrastructure in previous slides. Then you need to know a bit more on your core services. Your core services is divided into five categories. One is compute, storage, database, network, and then we also talked about CDNs, right? So you need to know compute. Achha, what are my options in compute? We'll touch base upon few of those. You need to know your storage. Storage doesn't just mean one particular type of storage. Storage could be block storage, file storage. There are different kinds of storage that customers need. Storage can range from hot to cold depending on the access patterns customers have. So there is a lot to discuss in storage in its own. Networking is, how do you create your own private network inside AWS? How do you ensure you have security when something is being accessed in your applications? So networking is a big topic in its own. Databases, I'll also show you what different levels or types of databases AWS has, but databases is where you're going to persistently store your information, right? So there are lots of databases to look for. And then you move towards the right, towards security and compliance. Now at AWS we say security is our number one priority, right? Because you are hosting your application into some location that you're not aware of, and you want to ensure that it is secure, it is compliant to the regulators, and you want to ensure that it is not tampered with, right? So from an AWS perspective, we will talk about the shared responsibility model, but from an AWS perspective, security is job number one for us, and that's why there is a lot of emphasis on the security policies. Now everything else that you see, from management tools to analytics to DevOps to mobile services, IoT, machine learning, we have a session, next session, by Suman. He'll take us through a lot of these things, talk about deep learning, but I will also take you through a lot of these services. And there are lots of these services, not so don't and here I'm not even mentioning the names of the services, right? These are just the uh, kind of services that we have, right? Then you have the marketplace. We talked about marketplace, I gave an antivirus example. And then there are a lot of different support that customer gets. So it could be like there is a support, AWS support, where you can reach out and ask questions and they can help you with troubleshooting. And there are a lot of other teams in AWS who can help you have a best experience at AWS, right? uh, so from a compute perspective, compute is virtual machines or instances, containers, and Lambda. Okay, so when you think of compute not just that's a virtual machine is my compute. No, compute ranges across a lot of different options, right? So from an instances option, you could have a lot of different options on compute, right? So you have AWS gives 275 plus instance types. How do you remember that? There are different categories. So there is general purpose, there is burstable capabilities, or use case specific. So for example, you're hosting maybe a database, right? And that database has a lot of requirement for memory. So you would look at memory intensive virtual machines in that case, right? Because they are optimized for that kind of a workload. Now, doesn't really mean that, okay, if that there is an R5, so I will only use R5. A lot of customers, to save cost, look for some other type of instance types, and then they do their own benchmarking, they do their own load testing to understand that this instance type fits this particular use case or not. Okay, and EC2 in itself is a very a deep dive conversation in its own, for that matter, but it provides you a lot of options, a lot of storage options that you can plug and play, a lot of configurations that you can look at and work with it. So try and understand EC2, because or try and understand the virtual servers parameter in AWS, because almost all of the managed services have the similar fundamental understanding of how EC2 is, right? And most of them really use EC2 in the backend. So having an understanding of EC2 works will help you understand everything else. Always have your base clear, and everything else will just sitting on top of that. So it will become much easier. When we talk about EC2, also talk about auto scaling. Now we talked about that, my application has more demand or my game has more demand, so I need more virtual machines. So there are services like auto scaling, in which you can add more capacity automatically based on certain metrics. For example, I have two machines, and both these machines, the average CPU is about 70%. Add third machine, and auto scaling will automatically add that. Oh, now I have three machines, and the average CPU utilization of three machines is less than 20%. I can shut off one machine and save on cost. So auto scaling, please shut off one machine and it will go back to two machines. And this way there is a lot of configuration. It's again simplified, but there are a lot of configurations you can do to save cost in that perspective. And auto scaling just doesn't happen for EC2. There are a lot of other services like DynamoDB, which is a NoSQL database where auto scaling can happen as well. So coming to containers, right? Containers, like you have Docker Hub, which is a public registry for Docker containers. You can also have your own container registry in AWS, called as Amazon Elastic Container Registry. Okay, you can store your Docker containers in the private registry on AWS. Then, from a compute engine perspective, there are two options. There is EC2, and there is Fargate. Okay, I will talk about Fargate a bit. but you have options. How do you want to manage the infrastructure? Do you want to manage the infrastructure, which CPU to be, which EC2 instance to be launched, how are they going to be scaled? You want that kind of control, go with EC2. You don't want that kind of control. You're one of those customers who says, hey, this is my Docker image, this needs so much CPU RAM, you take care of scaling, scale out, I don't want to worry about all that. That's when you go with Fargate. Okay, as simple as that. A lot of control, lot of convenience. EC2 is control, Fargate is a lot of convenience. From an orchestration perspective, we have two. One is Elastic Container Service. This has been since 4 5 years. This has been a service since 4 5 years, so very stable. Been there for a long time. We also listen to our customers. So you may have heard this that 90 to 95% of our roadmap comes from customers. So our customer said, hey, I'm running Kubernetes on EC2. Can you make it simple for us? Can we have a managed service for running Kubernetes on EC2? And that's where EKS came into place, right? So EKS has been there for almost 2 years now. So there is a lot of work that has been done with Kubernetes as well. Earlier, we used to only have managed master, but now we also provide managed nodes as well. Right. If you are interested to know more about ECS or EKS, there's beautiful workshops, pointed step by step, beginner, intermediate, advanced kind of level workshop. Both of them easy to remember: ecsworkshop.com, eksworkshop.com. Have a look at them, play with it, experiment. The more you experiment, the more you're gonna learn about these things. Last but not the least, we'll also talk about serverless. While Lambda is just a part of the serverless compute stack, there is also a lot more to serverless. Okay, and there's a lot in detail that we can talk about serverless in its own. Like you have API gateway, you have AppSync for REST or WebSocket based APIs, or you could have AppSync for GraphQL APIs as well. You have a lot of integrations, like you can create your own queues, you can have notifications, or you can have event buses. So there's a lot more into the serverless stack on AWS that you can have. So you don't have to worry about servers or databases and everything else, like infrastructure related stuff. You're one of those who are like, I like coding, I like to stick to it. Just give me a development console or take this code and execute it for me. I don't have to worry about infrastructure. Serverless is what you have to think about. I know a lot of you are interested in DevOps. While AWS won't really stop you from using the DevOps tools you are already familiar with, I just wanted to showcase the different types of DevOps tools that are available in the market today, right? There is a lot of IDEs. So even AWS has an IDE called as Cloud9. I use it regularly because everything is in the cloud. I don't have to worry about my MacBook crashing or something going wrong with it. I can just pick up someone else's laptop, log into my AWS console, and just do the demo. So helps me a lot. Uh, there's a lot of services that fit into, from source, build, test, to deploy and monitoring of applications. There is an interesting have a look at, if you're not already, at infrastructure as code. So we do have a service called as cloud formation, where you can treat infrastructure as code, write it into a template file, which is like JSON or a YAML based file, and give it to AWS cloud formation, and it will create all that EC2 and databases and VPCs and everything that you need in the background for you. So you just write a YAML or a JSON document, and it will do the magic behind, right? There is also something called as CDK. I like to talk a lot about CDK, so maybe in future I can do a session on CDK. But CDK is Cloud Development Kit. It is like, you write code, actual code that gets interpreted in a cloud formation template that you can use to create a lot of services in the backend. And now, because it's a code, you can also run it through the same CI/CD pipeline and automate the entire stuff. If you have to interact with AWS, a lot of support for a lot of IDEs. We have AWS toolkit for these IDEs. So if you're interested and you're used to some of them, just go ahead and start playing. With databases, a lot of database options, right? Relational to purpose built. Relational, you have a lot of options with Aurora, MySQL or PostgreSQL. This is MySQL or PostgreSQL that AWS has adopted, changed a bit, and created Aurora. With RDS, MySQL, PostgreSQL, MariaDB, Oracle's SQL Server, these are databases that provide these engines out of the box. So a particular version that is true to the community edition in the market. So that is how it's going to be with databases. There is also one serverless Aurora database where you don't have to worry about scaling or stopping and starting of servers. You can just start storing data into that and it will take care of that. When we say at AWS, right, you have to think of two perspectives. One is control, convenience. Control is you host everything from databases to whatever you need on EC2. Okay, and you worry about the whole thing of how patch management to do, about backups and installation and patch management. Everything you worry about, you take care of. It's all in your control. The other side is managed. When it comes to managed, different services have different flavors, but mostly a managed system where it would be installed for you. We take care of backup, we take care of monitoring, we take care of replication. Like if you're talking about RDS, we take care of how you replicate your data, or we take care of high availability, we take care of security. So there's a lot of things that AWS takes care of, right? And that's why we recommend our customers to use a lot of managed services, because they don't have to worry about it. They can worry about the application architecture, the application code itself, right? They don't have to worry about how infrastructure behaves in the backend. Then we also have these purpose-built databases. So if you have a key value NoSQL database like DynamoDB or document or in-memory or even graph databases that you need, they are available on the AWS platform. Quickly, there is the ML stack. It's been growing. I think this is not enough. It has grown further, but there is three different layers to ML infrastructure, where you have ML frameworks and infrastructure for data scientists who want to actually go deeper into the stack and take those decisions. Again, more about control. For a lot of practitioners who don't want to worry about a lot of that, but just want to worry about the code or the ML problems that they want to solve, then you can go ahead and look at ML services like SageMaker and many more, like the whole SageMaker portfolio. And then there are a lot of customers who are like, I don't want to do all that. I don't have any data science teams to hire. I don't want to spend a lot of money. Give me services that are easy to work with. Like with an API call, I should be able to work with that service. I give the data, I get back a response, and I'm happy. That's where the AI services come into place. Okay. So let's talk a bit about security, because I know there are some security enthusiasts here. So there is something called as shared security responsibility model that AWS has. What we mean by that is AWS takes care of the physical infrastructure security. They will take care of the locations of physical security guards and how the locking works. How do people log into that data center? How do they get access to it? Everything is taken care by AWS. Anything below the operating system or the hypervisor level is something that AWS takes care of. Okay, and you as a customer or the customers of AWS take care of whatever they put in on the cloud. So for example, you procure a virtual machine, right? You go into console and say, I want a Linux virtual machine. Now, anything beyond that base image of that Linux operating system is taken care by AWS. But anything above, like you go and host an application inside it, the security of that application is a customer's responsibility. Whatever data they're storing is a customer's responsibility. By saying that, we are not letting go of our responsibility. Obviously, it's on our platform. We are responsible for it. But not everyone looks at security the same way, right? So, for example, an enterprise customer would think about security very strong, from a very strong mindset. Like they have processes and policies for having secure applications, right? But a startup or maybe someone like a student may not want to worry about it. It's just something I picked up from GitHub. It's already public knowledge. I'm not worried about security, and they may not want it, right? So we can't enforce security at that level. It's a customer's choice is what protocols they need. AWS, however, gives all the kind of tools that a customer would need. Like we will give you firewalls, we'll give you web application firewalls, we give you DDoS protections, we give you a lot of things in out of the box, or services or features that you can configure for yourself, but it's ultimately a customer's choice. So security is a very big topic, to be honest. So security could be like, security of your code or your runtime security, and how a lot of customers look at is from a different perspective. So some of them would look at having security like inbuilt and no one should be able to tamper it. Some would think about it as immutable, right? So they would think of, oh, if something goes wrong with one of my machines, I can just terminate and something else will take care of it. Or there are different ways of thinking around security itself. So there are a lot of items at AWS end. One is uh, okay, I think I have this question to ask, right? So many questions come to us is, can I come and see your data center? It's like, no, you cannot come and visit an AWS data center. We as employees don't know where the AWS data center is. We cannot take our customers to our data center. And the reason is, if I take you, I have to take someone else, right? So no one knows where the data centers are. They're very secret, they're very confidential information. We do, however, give out a lot of these regulation auditing regulated documents to prove that the data center is secure, right? So we have a lot of documentation on that. We have a lot of certifications based on data center security that we can provide to our customers to prove how secure the data centers are. The second point is, there's a lot of work that AWS, or a lot of tools that AWS gives for encryption, for key management. Like I mentioned, we have a lot of firewalls, DDoS protection, and you can also use machine learning for, threat detection, or, any kind of security that you want to inbuilt into your cloud. So there are a lot of services, a lot of configurations that are available for a customer to choose and pick up from. So we talked about a lot of certifications. Uh, so while I'm here, I do want to talk quickly about, if you are on AWS Cloud, what would you do? Like, what are the typical things a customer should think about? And the reason I'm sharing this with you is because you're going to be a customer of AWS someday, or you're going to work with someone, and you should know these basic things that no one really talks about. And I'm hoping that we start a conversation around these, because I think that a good foundation is important when you're growing on any platform, right? So the first and foremost is having an AWS account. Okay, so it could be a AWS account that you've created, you've given your credit card details, and you've created a new AWS account. The first thing is obviously have an account. The second is, if it's for a company, it doesn't apply to individuals, but if it's for a company and they give, I've seen a lot of customers do this, they give something like, Arjun at the rate something.com, and as an email address. And what if Arjun leaves the company? What if Arjun doesn't look at his emails when AWS sends something important? The thing I ask customers is to always have group email aliases. So if you are part of an organization as well, who may not be like a direct AWS customer, it's always good to have email aliases, and then add a lot of email addresses into that email alias, because that will help a lot of people get that same message. And if someone leaves or something happens, you still can log into that particular account. The next one is a lot of account related strategies. I don't think I'm going to bore you with that, but a lot of customers don't realize this is, you can create multiple AWS account. You can have like, parent child kind of a relationship between them. You should, and there is an architectural piece to it. So I will also talk about that. Even if you have one account, you can have multiple VPCs. Like layering and adding more layers or adding more differentiations help secure a particular AWS account. And that's where I will talk about in my coming slides. How do you interact with AWS? There is an AWS Management Console for whoever who likes to do click, click, click. And everyone starts with AWS Management Console, right? Because it's easier for us to see what is happening and then follow a wizard. A lot of our customers use command line tools or the SDKs that AWS has to build their own applications or build their own scripts. Uh, you can use your IDs. I already mentioned about that. And I also talked about infrastructure as code, where you just write templates in YAML or in JSON and use that, right? Uh, how do you select a right region? A lot of good points here. One is application latency. Like I told you, where does majority of your users sit, right? Where do your majority of users access your application from? Consider the lowest latency being closer to your end users. Secondly is compliance and data privacy laws. So, for example, financial regulations in India say that all the financial transactions or data related to that should reside in India only. It cannot be outside India. So there are a lot of compliance and data privacy laws that are country specific that you need to adhere to. So if you have an application that needs to, you need to check, do we fit into any of those? Are there any rules regarding this? How do are there any laws regarding this, and how do we work backwards? Services availability. We talked about 175 services, right? Not everything is available in all regions. We try. AWS tries its best to have them across all regions, but not everything is available everywhere on day one. So if you are interested in a service and it's not available, go ahead and check the region table, right? So just to search for AWS region table, and you will find a fancy table that will tell you which region, which service, proper detailed information there, right? Majority of our services do come first in the US East 1 region, and it's the oldest and the biggest region that we have. So if you want, you can go ahead and use that. And last but not the least, the pricing as well. If you don't worry about all these three and you're like, hey, I want to just do some projects, I'm learning AWS, then maybe you want to find the cheapest region on the AWS platform, like US East 1. And you go ahead and create that, because for you, it's not going to matter, right? The latency, because you're playing, you're creating proof of concept, you're doing any performance test for latency, then maybe keep it closer to your users. But if you're practicing, playing, go ahead and do it in US East 1, because it's the cheapest region that you can find. And something that we did recently is enabling or disabling regions. This is very important. If you have an AWS account, please do this today itself. I'll give you a quick anecdote what happens, why to do this. We are human beings, right? So I've had this customer, and this was ages ago, okay, and this not very recently, but this has happened and keeps happening. Someone in this customer's organization wrote a code, and they embedded the access key and the secret key. These are like credentials for an account in AWS or an IAM user in AWS. And the credentials were by mistake put in the code, hard coded. The code went on to GitHub, and what happened was that there are always these bots looking for these kind of credentials, right? The bots picked them up, the account got hacked, and the hack happened not in the region that they were working in. So for example, if they were always opening up the Sydney region, they will always look at Sydney region, right? You as human being in the console or your APIs are always pointed to the Sydney region. So they didn't realize until some pricing budget alarm went off and said, "Hey, your monthly bill is now $1,000, $2,000." And the customer like, "How is that possible? We're not even halfway through the month." Then they realized, oh, someone got hacked into our account and they started these virtual machines somewhere else, and they were like, what do we do? And we helped the customer. Obviously, it was not their fault. We helped the customer strengthen the security and help them with the money as well. But the point is that these things happen. So if you don't want that to happen to yourself, just disable the regions you're not going to be working in. So that would be good. By default, I think new accounts have disabled regions, but just go ahead and have a look at that if you can. Quickly, security 101. If you have a root account is where you get that email address and the password to create a new AWS account, right? So that is called as a root account. There is something called as access key and secret key. If you have not created that, good. If you have created that, just delete it. Okay, you don't need it. Just delete that access key, secret key. Second important thing, for your daily activity, anything that you want to do with the account, Create an AWS IAM user. IAM is a service, identity and access management in the AWS console. Go there, create a new user for yourself. Use this user to log into the AWS platform. Create a new role or a user for any application access that you need. Ensure that you're giving less privileges, like you're just giving access to the services that you need in that application to that particular user key, access key, right? Enable MFA. MFA is very important. MFA is like multi-factor authentication. Do I have it somewhere here? I'm not sure. But MFA is multi-factor authentication where you can have a physical token, or you could even have a virtual token. Like you can use tools like Authy or Google Authenticator to generate a random, OTP kind of a thing, and then log into your account. This will help you secure your account. Always have a strong password policy. Cannot emphasize enough. There is a setting that you can specify what kind of policy you need, but always have a strong password policy. Now we are employees, right? Every 3 months, and I think it's today, that I have to change my password to my systems, to everything that I have access to, and that's because it is a good security practice. So have a strong password policy even for your AWS account. And rotate credentials regularly means that, don't just keep the same password or the same credentials for years and years. Keep changing over the time, so that, your accounts stay secure. And last but not the least, as I mentioned, give only access as much as you need. So grant least privileges wherever. It could be like firewalls, like security groups, or with IAM policies where you're giving access to particular AWS service or particular features in that service itself. The different purchasing options, I did talk about, electricity and the switch on and off in the beginning, but it's a bit more complex than that. So that switch on switch off kind of a thing is something like on demand. I need i need to charge my phone right now. I plug it in, I switch on, that's on demand. The second is provision, where I know that I need certain kind of capacity, and I need certain kind of uh, capacity. Like I need 10, like how we do with these cloud storage, where you say I need 100 GB a month. Okay, and I'm going to pay a monthly cost, but I need 100 GB a month, so I'm going to provision 100 GB a month, and you start paying for that bulk capacity. The last one is reserved capacity, where you say it's a long term commitment. It's a fixed long term commitment, where you could say, hey, I'm going to commit you that I'm going to use this virtual machine for next 1 year, uh, and in that the cloud will give you discounted pricing, right? So there are different ways how these services and how these features work, and a service could have multiple of these purchasing options. uh, so just to give you an idea about EC2, EC2 could be on demand, like pay per second. How many seconds that machine has been running, you will pay for that. On the website, you still see by hour, because second ka point. It's very difficult to do that kind of math. But you can have the idea, acha, per hour is so much, so how many seconds I'm going to be charged for. So that's on demand pricing. Reserve instances, it's like you make a particular commitment of 1 year or 3 year, and it also has a lot of configurations. You pay a significant amount upfront or later, or partial, and you get some kind of discount. How this looks from an AWS perspective. Now we do say cloud is virtually unlimited, right? But there is still a data center that AWS has to manage, right? So AWS still has to worry about creating servers and storage and having that space, and the whole gamut of things. If a customer is ready to commit and tell us that, okay, we are going to work for a year and we're going to use this kind of capacity, it takes care of a lot of things from our side, right? So we don't have to worry about a lot of things. Okay, now we know that this customer at least we have these many customers with this much basic requirements, and this we can keep up and running. It helps us, and that discount, or that way of thinking, or having that scale, economies of scale, we can give it back to our customers in manner of discounts. Now RIs or saving plans, both, I don't recommend any of my customers to do them on day one. So even if you are a student, Don't do these on day one. These are meant for customers who have run their applications for a month or two. They know what kind of workload they're going to need. They know that, okay, this is what I need and I need it for another year. Then they go ahead and reserve it. Because if you don't use it, you're still going to be charged for it. Okay. So if you're experimenting, do the experiments with on demand or do experiments with spot instances. Coming to spot instances is the free capacity that no one is using. It's just lying around in the AWS data center, and we give it at a very reduced cost to our customers. Now, years ago, this was 2 3 years ago, we used to do bidding, but we don't do bidding anymore. So spot prices are much like 90% cheaper than our on-demand pricing, and there's a lot more intelligence done with spot instances today with our customers. And this is very important because while cloud is cheap, that is the perspective. If you don't use it the way it has to be used, it's going to cost you a lot more, right? Free tier, something interesting for all of you. If you have a new account, for first 12 months, sorry, for first 12 months, you would have some resources and some services free of cost, right? For example, 750 hours per month of a Linux machine for T2 size, T2.micro size is free depending on regions, right? For a lot of customers. Then there are other two aspects as well. There are some things that are always free, like we talked about Lambda, right? We talked about the serverless compute option. So 1 million free request per month, always, like regardless of those 12 months or it's an old account, they will always have that kind of capacity free in the account. And the last one is there are some services that are given off on trial, like a 1 month trial or a 2 month trial, so that customers can play with it and they don't have to pay a lot of money upfront for a lot of these services. So, a nice tutorial. If you're starting with cloud and you are interested to learn more, I would request you to play with the LAMP stack. It's a simple LAMP stack, okay? There is nothing fancy here. But if you're just starting up, just follow the tutorial in the AWS documentation. It creates the virtual private cloud. It's like a logical isolation of the cloud for your account, for your region. Okay, it creates that. It will help you understand how you create these subnets, how to create security groups. Like security groups are nothing but firewalls. And how do you create virtual machines, how to create database server, how do you connect them, how do you connect to the virtual machine application. So it's a very nice beginners kind of a tutorial that I like to suggest. This is an animated slide. Don't worry, it's not a blank page. What I'm trying to show you here, that lamp stack that you created, how does that look at an AWS side with best practices involved? Remember, I have been a solution architect. I have seen so many customers not even doing the basic best practice with VPC and like basic as a LAMP stack, right? Or a 2 tier or 3 tier application. So when you think about AWS has a region. So the white box is the region. It could be a Mumbai region, okay? And a region should have at least two availability zones. So my application should be hosted in at the least two availability zones. So if one dies, my application still continues to run from the another one, okay? Then you have VPC. So what VPC is nothing but virtual private cloud. It's like a self isolation in your AWS account, and a VPC is a region based VPC. Okay. The next is you create something called as subnets. So you have public subnets, you have private subnets. Public subnet is anything you create inside a public subnet will be accessible over the internet. Anything you create inside a private subnet will not be directly accessible over the internet. It is only the subnets in between can talk to each other. You can define that in the route table, but nothing from outside is accessible. Now, you don't go and say in the console, say, oh, you create me a public subnet. No. How are these defined as public or private subnet is based on the route table. So there is something called as a route table. It's like a router in a normal language, right? It's a route table where you say, oh, give it an internet gateway, and then that becomes a public subnet. Give it don't give it an internet gateway. Don't give anything, then it's a private subnet, something like that, right? So you create public subnet, you create private subnets, you create security groups. Now, if you notice, VPC is region specific, subnets are AZ specific, But security groups are not easy specific. They are VPC specific. Okay. So they can span across multiple different subnets. What I'm doing is I'm doing tiering of my security groups. So all my web applications go into one firewall, all my database go into another firewall. So what I mean is security group. You can find a lot more information in the documentation about security groups versus NACL. Security groups, stateful firewall, NACL, stateless firewall. Okay, so there is a difference between stateful and stateless. There's a pretty good table that explains how they are different and what can you think about. But AWS provides both stateful and stateless firewalls for you. The next is create EC2. That is virtual machines, right? You can create virtual machines here, okay, create virtual machines there. And then we talked about auto scaling, like, adding more machines when the game is in demand, removing machines automatically when the game is not in demand. So you can do all that automatically using auto scaling. One tip, do auto scaling on stateless applications, not on stateful. So because auto scaling will terminate a machine, right? It will terminate a machine when your demand is low. What happens to the data that was sitting on that machine? So the data cannot reside on that machine. The data needs to persist somewhere else in a separate data store that is away, that is not that virtual machine, right? So having statelessness helps in applications. Add an elastic load balancer. A load balancer now, because you have added auto scaling, you have so many virtual machines. Each will have its own IP address, randomly generated. How do you identify them? Just put them behind a load balancer, because now load balancer will give you a DNS ID that you can give your users to access the application, and the IP address, addition, removal, everything is automatically taken care by auto scaling and elastic load balancer. Okay, so they talk to each other and they take care of the communication. You don't have to worry about it. Last but not the least, the database, right? So in the example, you can create an RDS example. RDS primary machine, primary server, where all the applications will access the primary, will write into primary, will read from primary, everything from the primary. If an application, if the primary fails, there is always, if you choose the multi-easy option, there will be a secondary in another availability zone. There will be a proper failover to another security secondary zone. A good question I keep asking a lot of people when I interview them for AWS is, we have a whiteboarding round, right? I ask them, how does this failover work? And not many can answer this question. I want you to go ahead and research, how does this failover work? How does your applications automatically know to point to a primary or to a secondary? What happens behind the scenes? See, these are the things that not many people think about, and because they don't have understanding of the basics, right? So you need to understand how these things work in the backend, so that then you can architect applications accordingly. I'm like, okay, if that service doesn't give it to me, I still need to think about these things in the long term. Okay. uh, so while that was the best practice architecture, a lot of customers will have maybe a single account, and you could have multiple accounts. Definitely recommended to have multiple accounts for prod and non-prod, so that you get, think about it like having two different houses, and then each house has its own different billing, electricity billing, right? So how much I'm spending with prod account, how much I'm spending with non-prod account, and then you can take those discussions, such as you're spending a lot with development, we need to cut it down, something is wrong, or you're not shutting down your virtual machines or something like that. So you can do that hygiene when you have different account. But if you have a single account, you could still do a dev VPC. You can still isolate everyone from the development to host it in the development VPC. You could have a staging VPC where you need to scale for load test or do all other kind of testing that you need to do with your application. And then you would have a production VPC. And not everyone gets access to production, or application deployments happen through CI/CD or through DevOps. Only infrastructure administrators get access to the infra in production. No one else gets access to anything else, right? So that is a best practice that a lot of customers must follow, and good to learn. Uh, Last segment is about learning. So what do you do? Where do you go from here? Uh, uh, Confession, there's a lot of links that I actually post in the next slides. Don't worry about all these links. I have I have uploaded these slides. You can access them. You can click on the links from those slides. So don't worry about taking screenshots or noting these down. So learning paths. If you have to learn, there is something called as learning paths on the AWS platform, and they are separated from like different roles, different solutions, or different specialities that you may be interested in. From developer center, you can also find a lot of samples on workshops, and some code samples that you may want to start with and then modify it and experiment on your own. A lot of training modules and everything is listed in one of those URLs, so you can have a look at that. uh, Remember the ECS workshop? Those are also part of these links. AWS has a lot of free content, so you don't have to really always pay for something. If you want to, go ahead and do it. Because if we pay, we are going to be more attentive. But if you are one of those who are just getting started and want to do it for free and see how it works, there's a lot of hands-on tutorials, a lot of hands-on workshops, a lot of projects that you can look for. And the reason I'm mentioning that big data, DevOps, databases, Teller, because I get a lot of questions saying, hey, I'm a developer. Is AWS for me? Yes, it is. Because AWS is not just infrastructure. Remember that T or breadth of services that we saw? AWS has everything for everyone. So if you are in machine learning, there's something for you. If you're into databases, there's a lot for you. If you're one of the developers, there's a lot of content that you can look for, that you can build. So there's a lot for everyone on the AWS platform. And there's also free digital trainings, so that you can go ahead and do that. There are also paid ones, so if you want. This how to be certified. There are different certifications AWS has. A lot of people say that, hey, I want to do professional. Do I have to do associate? Not anymore. You don't have to do associate of any kind if you want to go ahead and do professional. But please note that we do recommend that you do the associate one, so that you don't face issues when you go to a professional one. But if you want to do professional or specialty certifications, just do that. That should not be an issue. uh, yeah, and they are quite difficult, so please prepare for them very well in advance and then do them. uh, Last but not the least, a couple of slides more and then I'll hand it over to Suman. Machine Learning University. So if you are interested to in machine learning, go to aws.training machine learning, and there's a university that will help with learning paths and with a lot more data that you need. uh, Last slide. There are a lot of AWS events and conferences that keep happening over the year. Most of them are in person, but with COVID situation, we are all going online with most of them, at least for this year. There's reInvent is coming. We have just announced reInvent. It's one of the biggest conferences of AWS. A lot of announcements, a lot of fun that happens with reInvent. AWS reInvent generally used to happen in Vegas. This year reInvent is happening free online for everyone. Okay, so go ahead, find it, register for it. There is AWS Summit that happens in India around April-May timeframe, and it has happened online this year as well. There's Community Day coming up. It's happening in October. So please do, sign up for Community Day, because it's from the community. It's not really an AWS event. It's our user groups who are coming together, and we are doing one India-wide community online this year. So we are super excited for that. So do that. And something that I've not pasted here, but we also have a Women in Tech Day, only for women. Sorry. And we are doing that online as well in September. So if you follow me on LinkedIn and Twitter, I keep talking about a lot of these things plus tech for a lot of my videos. So please do follow me on these different channels. The slides are available on SlideShare and Speaker Deck. Just search Rohini Gaonkar and you should be able to do that. And with that, that's the end of my presentation. Sorry. And I'm going to add, thank you for that. I'll just remove my screen. And I'm going to hand it over to Suman. Hey, Suman. Suman, are you there?
Yeah, can you hear me okay?
Hey. Yes, I can hear you. So handing it over to Suman. Thank you for your time, and I'll just remove myself. Oh, I think Suman just disconnected. One second. Hey,
Yeah.
Suman.
Okay.
All okay?
Hey, hi. Sorry. Yeah, it's fine. So I can share my screen. Just give me a moment.
Yeah.
Okay, cool. Um, all right. Thank you so much, Rohini, and thanks so much for there are a lot of content we discussed, and I hope that it's quite overwhelming, as Rohini mentioned, right? The kind of services that we have, and especially if you are new to cloud computing and to AWS, it would be a little overwhelming. It's not only for you, but for everyone, including myself, right? So almost 70% of the things which Rohini mentioned, I have no idea about those, although I'm with AWS for almost a year. So a couple of questions that I was just reading through the chat. Thanks so much for all your feedback. Highly appreciate all your inputs. So one of the question that one of the participant had was, since AWS is managing all the data center and infrastructure of their own, is there any probability that someone can go physically inside the data center and access the resources? So it's not possible. Literally, it's not possible. And few of the things Rohini mentioned as well, that even an employee cannot get into the data center. And honestly, the employees do not even know where the data center is. But if the team who is taking care of the data center and other operations, they are also not allowed to get inside. Okay, so we do have a strict compliance, and we have to understand that AWS has been used by not only startups or e-commerce vendors, but used by federal government agencies, security agencies, etc., like US Department of Space and all of them. So there, the information security is the topmost criteria, right? So they will never host anything on AWS unless and until they have all the checkbox as per the security is concerned. So it's pretty much secure, and in fact, it is more secure than what we have in on-prem. I've worked, all in on-prem kind of infrastructure all my career, for last 12 years. So, and now when I see how AWS runs, it's pretty different. Okay, so there is no concern from that side. Okay, so one more thing I will, just in case I forget, just ping me in the chat towards the end. I'll also talk about how you can create your free account if you have your university email ID. We have an Educate program. Maybe I will show you how to log in and create an account. So that would be something interesting. You can straight away go and start playing around the things that Rohini just mentioned, in her presentation. All right. Okay. So uh, firstly, thank you so much for joining in. And I know it's 2 hours is quite long, and I will try my best not to complete this within next 1 hour. So you can have grab some water, and feel free to ask questions in the chat. So whenever I switch over from my presentation mode, I can try to answer, or maybe after the session, we'll try to answer that via various mediums like LinkedIn, Twitter, whatever you feel like. Okay, so. For next 30 minutes or so, what we are going to do is we'll just touch base on what deep learning is. We will try to understand one part of it, MLP or maybe CNN, whatever you feel like. And then we will try quickly go to console and play around few of the things. Rohini has already mentioned, and few of the things that we will cover over the period of time. Okay, so I'll just go over a few of the slides quickly. And by the time I feel myself, I get bored of my presentation, I will switch over to console. Okay, so I hope many of you know him. Can you tell me who is he? In the chat, I will read through later on. So the idea is, if you look around, artificial intelligence is everywhere. All right, so we are consuming that in every possible sense, starting from using our, using a cab to commute or order a food from various delivery agencies, or using our laptops, smartphones, etc., right? So we are using AI in some other way, right? And the idea that we have is, especially the expectation that we have from you all guys, is not to become an end user of that, right? So be a part of how you can contribute to this whole new technology stack, right? So develop few things rather than playing something which is enabled by AI. Try to build something using that. So that will fetch you quite a good value over the period of time once you graduate from your university. And we do have all the resources and documentation, training, etc., to enable you so that you can go from there onwards. Okay, so AI is everywhere, and this is a very good time to pick up that. And it's not only for computer science background engineers or electronics background engineers. It's for everyone, basically. So you can, even if you are from mechanical, electrical, whichever domain you are in, you can always stitch this to your specific workflow, right? So because you can think of it as a as a supporting technology which can make your application or work more smarter, right? This is the way you should think about, rather than just think about AI as a bunch of algorithm and you need to be a ninja in linear algebra and all of that, right? So that is not something that fascinating. But if you think from application standpoint and then think backward, then the learning would be more interesting. Now, if you think about it, there are lots of articles discussing about what is AI, what is machine learning, and what is deep learning. So I don't want to repeat that, and you can define your own, definition, whatever resonates well. That is not the point, how we define. But the basic difference between all these three is, AI comes under, the bigger umbrella, which is kind of a mother of everything, and you can think of it as a, the application for AI would be a system or a computer which can think like human being, right? So because we as a human being, we think pretty fast, right? We have an enormous power to understand and take decisions in a fraction of a second. If we could able to make a computer or a system for that matter who can think like us, then we can define that as a AI-enabled system. So, like smart, your smart cars that we have, autonomous cars that we have, right? So things like this. Now, this is the end product that we are trying to build, but how we can actually build that. So there comes machine learning, which has the nuts and bolts to, with all the algorithms or the statistical theory, probability, and all of that, technical stack, which actually tries to find the pattern from the data, right? And then it will try to predict. So that is the whole idea of machine learning. It is not like like, let me just use my pen. Yeah, it's not like you are given a problem and you know the formula to find the value, right? So let's say you have something X, and this X may be, let's say, you are asked that whether this number is an even or odd, right? So what you will do, the formula how to find a number is even or odd, right? You will just divide by 2. If it is denominator is remainder is 0, you will find that it is an even number, right? Or else it is an odd number. So this formula, right? So this is known to you, right? So basically this function, whatever is this fx function, this is known to you. So this is classical computer science problem or classical computer science program that you might be writing in C, C++, or whatever, right? But in machine learning, it is not the way this works. So in machine learning, what happens is you are given lots of data, right? So let's say x1, x2, like this. You are given lots of data, and you have given lots of output, right? So let's say the output of this is y1, y2, and so on. But you don't know the mapping function. What is the relationship between this input and this output, right? And your objective is to find this function fx. Okay, so fx is the function that you really want to find out, but you don't know the formula, so you cannot write a code based on that logic, right? So the only way that you can do it is you have to go through all these data, It's this is the input data, and you can think of this as a class or the label of this data, and you have to use some algorithm, some magic function. Okay, and once you pass through all of that this data, you will come up with some function fx, some complex function fx. Okay, and after that, given any new input, it should be able to predict. So it can give some prediction. Okay, so this is the whole crux of machine learning, that you have to find this fx function. And how we can find that? Using statistics and machine learning algorithm like decision tree, k nearest neighbor, k-means algorithm, xgboost, etc. So those things, few of the things I'm sure that you have also studied in your data structure class, like data structure, decision tree, and etc. Right? So this is the whole idea of machine learning. So you have to find out that fx function given all the input and output, or the class labels. So if you can imagine that for this to happen nicely, you need to have lots of data. If I just give you 2 data points, you cannot find a function which can predict with higher accuracy, right? So you need to have lots of data for this. Now, deep learning, on the other side, is again a subset of machine learning, which is focused on few of the tasks which are very complex in nature, which cannot be efficiently done by classical machine learning algorithms. Right? So example would be, let's say you need to find out an image contains your face or not. Like today we use smartphone with face recognition, right? So it unlocks your phone automatically. So these kind of problem is very difficult to build. So image classification is one of the toughest problem that we have in machine learning even today. Okay, so that is very important, that how you can find an image contains a particular object or not. So let's take an example, right? So let's say this is an image, right? And this contains a dog. Now I have to find out that this dog is present in the in this image or not. So this would be the input, and output would be like yes or no. If there is a dog, then it's yes. If there is no dog, it should be no, right? So if you apply traditional machine learning algorithm, what you have to do is you have to find out what are the features of the dogs, like how the tail of the dog looks like, and how long the ears of a typical dog are, and all of this. So you have to extract a lot of feature, and you have to give the algorithm all those feature information. So basically, you have to give the feature information to the algorithm. Only then a machine learning algorithm can find out whether an image contains dog or not. Whereas if you use deep learning, you can simply give this image, and it can automatically extract feature out of that. Okay, so you don't have to give explicit details about the feature. It can automatically find out what are the features that comprises a dog or a human or whatever for that matter. Okay, so in a nutshell, deep learning can solve a lot of complex problem, and how it can do that is using feature extractors. So in machine learning, you have to explicitly say which are the features which are important and all of that. But in deep learning, you don't have to do this. So that also resonates that, okay, if deep learning can do so, then it can also do the task which machine learning can do. Obviously, yes, it can do that. But is there a point to use deep learning for all the problems? The answer is no. The reason is, for deep learning to work, you need lots of data, Like even if you want to classify, solve a problem, or to find a dog in an image, you need to add at least 1,000 or 2,000 images of various dogs. So that's the amount of images that you need to first find out, and that also will not give you a good accuracy. You have to come up with, let's say, millions of images. Only then you can find out a good solution or a good model. Whereas in machine learning, classical machine learning, you don't need that much of data with respect to how much the data that you need for deep learning. And that is the reason we need a very high system, a computing power system like GPUs and all of that for deep learning to work. Okay, so these are the three various different, different areas of artificial intelligence. So machine learning, deep learning, and obviously the AI. And deep learning is mostly for complex problem where we don't know the exact feature, and we want the algorithm to extract features out of our data set. Right. So this is the difference. Now, if you look at the history of machine learning, This is not something very new. So if you read about deep learning in particular, you'll find that these things are like back propagation. This was in fact it was, I guess, 1956 or somewhere in that time frame was discovered, and it was talked about. And then what happened is, over the period of time, from this 1956 till I think 2006 timeframe, there was kind of a snoozing period. People could not able to do much. Although these these concepts like perceptron, we will just look into it in a minute, and back propagation, these things were there in 1950s and 1980s. If you pick up any book, you will find that. But things could not move that fast, until 2006 timeframe. And apparently, that is the exact year AWS was formed. So why this happened, right? What was the reason that this happened? Because these phenomenal, professors like Professor Frank, Professor Allen, they all were thinking at that time itself that how they can make a system which can think like human being. And one of the reasons that it could not able to do is they did not have enough data at that point in time. Right? So today we have hundreds of GBs of memory in our smartphone. Right? When I was in college, even to buy a hard drive of 80 GB was beyond the scope. Considering the budget that we had. But now we are carrying smartphones with hundreds of GB of memory. Right? So data was a challenge that time. Then one other thing was the compute was not that easily available. Right? Until last 15 years, I would say, even a system was costing more than a lakh, right? A standard desktop with a good configuration. So these things were not there. And without these two, you cannot run any algorithm, or you cannot do anything, that critical, which we do today. And over the period of time, what happened is we came up with lots of frameworks. So different companies came up with different frameworks like TensorFlow, Caffe, Torch, MXNet, etc. So now we have all of these. And the reason that we have all of these is because of the advancement of cloud computing, which Rohini mentioned a few of the things, that we have lots of different types of EC2 machines with different GPUs, CPUs. You can pick whatever you want. Once you're done with your work, you can just destroy that. Okay, so this is the whole idea of the emergence of deep learning, which enables us to do all of these fantastic work that we see around the globe, like speech recognition, natural language processing, autonomous car, image recognition, etc. So how this whole things work, how the deep learning work, is actually work. So this the core concept behind that is it is basically called artificial neural network, and this neural came from human medical science and biology. And the idea is we are trying to mimic the human brain, right? So that's how the neural network name has come up. So the idea is we need to build a network of neurons, and every neuron will be fired based on some ignition. Okay, so what is that ignition? How all this happens, we will see in a moment. But the idea is just to mimic our human brain. Okay, so now let's see how this whole thing works. Okay, so let's say this is this concept of perceptron is nothing new. It's there in from 1956. Okay, so you can think of this circle as one neuron. Okay, and in our human brain, we have billions of neurons all connected to each other, and everyone is talking to each other, and that's how we smartly take action in a fraction of a second, right? So we are trying to mimic that in a computer system. So how we do that? So we call it as a neuron. Okay, and these are the input. So you can think of this as an input layer. Okay, and this input can have n number of features. So let's say you have a data set. Let's not talk about okay, let's talk about an image only. Okay, so let's say this image is of 10 by 10 pixels, right? 10 by 10 pixels. So how many pixels I have total? If I just convert it into a vector, it will be 100, right? So you can think of this input as x0 through x 100. Okay, so these are the all input features. All are different input features, right? And now, what is this? This is something called a connection to the neuron, and it has something associated with that, which is nothing but weight. So now, if you think about it, what weight is, let's say if you have a data set like this, right, where you want to predict, let's say, I will go for shopping or not. Okay, this is let's say I will go for shopping or not. This can be yes or no. Okay, or 0 or 1, whatever you think, whatever you consider. Now the features are, what is the date of the month, what is my salary, whether I have any mall nearby or not. So let's say these three features we have. Okay, so now if you think about it, whether I will go for shopping, it has a very strong correlation with my salary, right? I mean, I'm considering that we don't have credit card, so it has a very strong correlation between salary, and it also have quite a strong correlation between the date of the month, right? Because salary finishes within the first week, so that date might signifies whether I will go for this shopping or not. So there might be some other field, like let's say my name, right? So my name has no such significance for my actual problem, whether I will go for shopping or not, right? So let's say my name is this feature. Okay, this particular neuron or input signifies name. So in that case, the weightage for this particular feature would be very, very less. It would be very, very less, right? Whereas let's say this is my salary input feature. In that case, this weight would be very, very high, right? So weight is basically to extract which is the right feature which has an influence to the output. Okay, so you have to think about it in that way. But obviously, we don't know what should be the weight, right? We took a very simple example. By looking into the data set, we can figure it out. But ideally, these weights are not known to us. Okay, so now, so the point to take from here is every input is multiplied by its weight and then send it across to this neuron. And what we do here is we first sum all the products like x0 w0 plus x1 w1. We just sum it all. Okay, and then we do something called activation. So that means we just wrap that output, okay, via some function. So let's say the output of this is a. Okay, and then this is a function. So this function adds linear or non-linearity to the output. Okay, so what do we mean? What do I mean by non-linearity? So if I do not have any activation, in that case, my input would be a linear function of this output, right? Because there is no, it's because it's a dot product, right? It's just a product of all these weights. So I cannot have a very complex function. So let's say if I have a line like this, right, or a line like this, I can always have a function by this dot product, right? It's just y equal to mx plus c. You can think of it that way, right? But let's say I have a function like this. This is not a linear function, right? How can I define a function like this? For that, I need to have some non-linearity, and we do that through some activation function. Okay, there are different kinds of activation functions available, but this is what we do in the activation. And there is something called bias. So a bias is something that not always is there, but bias is independent of all this input feature, right? So let's say you have to take, let's say you have a problem that whether you want to go out to play cricket or not, right? And these are the features that you have, your friend is there at home or not, you have the cricket kit with you or not, and all of that, whether it's raining or not. So these are the input features. So these all are important to take a decision whether you will play cricket or not, right? But let's say you are sick, right? You are sick. So in that case, no matter what is the input feature, your output will be always know that you will never go to play cricket. So bias, you can think of it that way, all right? That it can influence, or it can skew your output. And the whole idea of deep learning is to figure out the right value for these weights and the right value of this bias. Okay, this is the whole idea of neural network. Initially, you just start with a random initialization. So you will just allocate a random number to W0, W1, W3, and till Wn, and then you try to learn. Okay, there are different ways that how you will learn. I mean, we'll just go through that in a moment. But basically, you have to figure out what is the right W for your problem, right? So these are the activation functions that we have. One is like, this is a normal activation. I mean, this is a binary step function, right? Which has a very strong transition. It's not a smooth transition, right? So this is not something that people use. Generally, a lot of people started with sigmoid, which was the first activation function with the community users and scientists used. And if you see, the sigmoid function varies from 0 to 1, right? So given an input, it will vary from 0 to 1. And it's basically sigmoid function is 1 by 1 plus e to the power minus x. So whatever is the x is nothing but this value, the product of this, right? Whatever you got, and plus the bias. So basically, whole of this, right? So if you pass that input to this function, it will vary from 0 to 1. This is what sigmoid function is. And then we have tanh, which is also an exponential function, but here it varies from -1 to 1. But if you look at it, all these values actually squeezed between 0 to 1 or 1 to -1, right? So there are a lot of implications for this. If you we can go deep on that, but there are a lot of limitations, and scientists thought that this is not the right way to do it, and let's come up with some new activation functions. And then we got ReLU. So ReLU is relatively a new activation function, and this is what people use across the industry. So just like any academic project or research thing, we try to complex things. Okay, this is, at least I feel that way. This ReLU stands for rectified linear unit, I guess, but it sounds very complex. But what it basically do is, if you pass x, right, what ReLU does is, if x is positive, then the output is always x. But if the x is less than 0, if x is 0 or less than 0, then the output is 0. That's all. It's as simple as that. But they came up with this complex terminology, ReLU. So basically, if that's why you see there is nothing in the left hand side, because if anything is less than 0, it diminishes. So it doesn't have anything. Now this became very popular, and then people started to think about it, that okay, how we can improve beyond this ReLU. Then there is something called leaky ReLU, because people thought since we don't it is completely diminishing in less than 0, let's not diminish the output. Let's have some let's have something for the negative values as well. So that's why the 0 is here, right? If you look at it, 0 is here, but it is slightly below that 0. The reason is, we multiply now with 0.1. So whatever is the x, we just multiply with 0.1 if the number is negative. So that's how leaky ReLU came into picture. And then as in the research people do in different universities, they started to work on this, and they came up with different functions like SELU, PELU, and I'm not making this names. These are there, you can find it out. But basically, people still use ReLU. That is the most performance efficient activation functions that we have till date. Okay, so now in deep learning, we typically have 3 different subsets, like MLP or multi-layer perceptron, which actually uses the concept that we have just learned. And then we have convolutional neural network, which is mostly for image processing, image segmentation, image classification, etc. And then we have recurring neural network, or RNN. This is mostly for time series information, or speech recognition, or speech detection, kind of problem. So let's say if you have to translate English into Hindi, right? It's very important that you listen to my sentence as it is. You cannot just save the words that I say, right? Because if you just save the words that I say without keeping a track of the sequence of the words, you may not be able to convert it into the different language, right? Because sequence is important. Because in machine learning, most of the time we don't care about the sequence, right? We just take the data, we can vectorize that, we can convert it into matrix or whatever, right? Because on those type of problems, sequence is not that important. But the places where sequence is very important, we use recurring neural network. So what we are going to do is we are going to see MLP today, and then we will go to a demo quickly. So what MLP is just like what we have discussed. We have neurons, but now what we are doing is we are adding lots of neurons in the same layer, and then we also have multiple layers. So initially, in the first example, we had input and we have just one neuron, but that that doesn't give a good prediction, because that you cannot do much with one single neuron, right? So to add more complex, to find more complex functions and all of that, you need to have multiple neurons. Now, what should be the number of neurons, how many layers it should be there, those are like, you can forget about it for now, because it's all based on experiments. There is no such formula which can tell you that, okay, this is the right number of neurons that you should have in a layer, and this is the right number of layers for your application, right? Or for your problem. But the idea is you should have multiple layers and multiple neurons based on your problem, and you can keep on trying which works the best. But this is the architecture, and we call this as a fully connected. And the reason we call this as a fully connected is each neuron's output is fed into all the other neuron in the next layer. Okay, you have to remember this. Every layer is connected to the previous layer's neurons, and that's why we call it as a fully connected. Okay, so the output of this neuron goes to the input of a layer 2, right? So again, this every neuron will have something called initially it will sum all the products, like dot product of x0, x, and w, and then it will have some activation function, maybe relu or sigmoid, whatever it is, and then that output will go to this layer, right? So this is how it all works. And at the end, you will have the output neuron where you will actually do the prediction. So let's say this is an problem of finding out a number, a digit, like recognizing a digit. So you can think, although this is an image, but you can think of it that you have dismantled that image into a vector, right? An array of numbers. So this is a digit 4, and you will train in a way that you will get some output. Okay, so maybe 5. And how we are doing it and what is the output layer, we don't know. We have not discussed yet, but this is the whole idea. But from this, you can find out that when you first pass through the data, you have all these weights, all are randomly initialized, right? And we have not mentioned, but here also you will have weights, right? All these links will have weights, but these all are randomly initialized. That means there is a high probability that the prediction would be wrong, and which is the case, right? Always, most of the time, right? So now you have to correct those weights, and how you can correct? Just like how we correct ourselves. We see that what is the difference between the actual prediction and the actual class level. I mean, the predicted value and the actual class level, and we try to make respective change in the weights. And this is what we called back propagation. Okay, so we find out the error of our prediction with respect to the actual class level, and actual class level is 4. We know that, right? Because we are only passing the data, and now we have to find out the loss. So now there are different statistical ways to find out the loss, like mean square error, log entropy error. I mean, there are different types of loss are there, but you just have to think now that loss is nothing but the difference between the predicted value and the actual class level. That's all. And now what you do with that loss? Now with using that loss, you try to update all these weights. Okay, and there are different algorithms available, or different optimizers available, like stochastic gradient descent and all of that. And now when you do a back propagation, you go from the output layer towards input layer, and you keep on updating all the weights. You keep on updating all the weights, right? So you keep on updating all the weights. And now once you are done, once you reach to the first layer, then again you go forward. Okay, and like this you keep on doing, keep on going and update the weights until what time you will keep on doing this, till you get a good amount of accuracy, or you are satisfied with your model, and then you can stop. Okay, and this is the point is, this is fully based on experiments. Okay, there is no static rule that you need to do this 100 times, 200 times, or whatever. Okay, so this is how the whole thing works, and the idea about this whole thing is, we call it as a training period. Okay, and in the whole training period, you do forward propagation and backward propagation, back propagation, and after every step you update the weights. And once it is done, you just stop, and then you say that, okay, my model is now ready. You can just give your input, and I will predict something. At that time, it will not update the weights, because weights are already been updated. It knows what is the right weight and all of this, so it will just do the prediction. Okay, so I will not go through this, because this is the same thing that we discussed. The only difference here is in the output, how we identify the numbers. So basically, what we do is, at the very output layer, is we use some function called a softmax. There are different techniques to do so, but let's say this is a problem for image, not image, number classification, 0 to 9, right? So there are 10 different digits. So I want a probability distribution of 10 different output nodes, right? So what I do is I will have a list of 10 numbers. Okay, list of 10 numbers, and each number will signify the probability of each digit. So let's say the first one is, let's say 0, 1, and the second is, let's say 0.9, and let's say 0.001, like this, so on and so forth. And then we may have last 0.02 or something, right? So this means that this particular neuron is activated. So this is nothing but this signifies digit 1. So let's say if I start from index 0 till 9, right? So in that case, this neuron will have the maximum probability, right? And so I will say that, okay, the output is, the number is actually 1. Okay, so the softmax function is also actually a function which gives you number between 0 to 1. So if you sum all this number, you will find the summation is 1. Okay, so given the whatever you give the input to this softmax function, it will, using standard deviation and mean, it will normalize the data into a probability distribution. So that's the whole idea of softmax. Okay, you don't have to write the code for all of this. You have libraries to do so. But since you are into college, I would strongly encourage you to implement that of your own and then compare. That's a good exercise to play around. So, but this is the whole idea of MLP. Okay, so we use softmax at very last end to find the probability distribution. In fact, probability is a wrong term. We should say that the intensity, whichever neuron has the highest intensity, that should be your class label. So like this is here, the 5 has the highest intensity, right? So rest all or nothing is there, so you can consider this as 0. Okay, so although most of the book says probability, but the right way to look at it mathematically is the intensity. What is the neuron which is having the highest intensity, because that's how our brain also works, right? So now, if you look at it from AWS, how you can do all of these. So this is one of the snippet from our reInvent conference. So reInvent is our annual technical conference, happens in Vegas, and he's our CEO, Andy Jesse. So this, Rohini already mentioned. We have 3 different layers. We have a lot of AI-based services like Poly, which is for text to speech. And the reason I'm saying this is there might be some quiz, so you may like to pay some attention because questions are around, these things. So then we have a lot of services like Comprehend, which can find the sentiment of any text that you give. And for all of these, you don't have to write any code as such. It's all built in. So all the training has been done, the model has been deployed, and you can use through endpoint or through an API, right? So you can just send a curl request and you can find the prediction. Now, what we are interested in today is either in these two layers where we have ML infrastructure, where you can create an EC2 machine, which is nothing but a virtual machine with inbuilt, framework like PyTorch, TensorFlow, and all of that, and you can just go and start write your code. And then we have SageMaker, which is a managed service, and here you can not only write your code, but you can do experiments like with various hyperparameters and all of that. So when I say hyperparameters, you can think of it like whatever we have learned and whatever we have said that we need to experiment a lot, all those things are hyperparameters, right? Like number of layers, then what is the activation function we should use, relu or selu or pelu or whatever, right? So all these experiments, you can do it there, and you don't have to do it of your own. It can automatically do, and it can tell you what is the best model, which is the best model, so that you can pick and start using that. Okay, so now what I'm going to do is I'll just exit from here, and I will try to open the console. Okay, so this is the AWS console. Once you log in, whether you log in through Educate account or you log in through your personal account, you will be finding this console, and then you can search for SageMaker. And once you get into SageMaker, there will be a lot of options here, like a Jupyter notebook, where you can create a Jupyter notebook. So I can quickly show you that. So Jupyter notebook is nothing but just like a Jupyter notebook that you use in your laptop, but this is completely managed, right? So you don't have to install any packages or anything. Everything would be there the moment you spin one. So basically, we create a container in the backend. So you can click on create notebook. You can give some name. You can select one of the type of instance, and what these instances are. You can check the documentation. All of them have a different CPU, memory, configuration. You can pick any of them. And then you can also use something called what is that? Yeah, you can also use the volume attach. I mean, if you want to download some data from Kaggle or anywhere, you might need a storage, right? Which this instance should have. So by default, it's 5 GB. You can increase that to 20, 30 GB, whatever you feel like. Maximum is 16 terabyte. And then you have to grant some permission, and then you can click on create, and it will be created. Right? So that's how a notebook you can create. But today, what we are going to do is we go to a SageMaker Studio. So this is recently launched last year, which is kind of an IDE kind of environment which you will get in the browser itself, which is very nice to use. So, and you can also share your code across your teammates or colleagues or whatever. So you have to add your user, and once you add, you can just click on Open Studio. So I guess I have opened that. So this is the console that you will get. It is not typical Jupyter console, right? So because you have lots of options on the left hand side. So you have experiments, then you can have all the options. If you want to change the kernel to let's say PyTorch to TensorFlow, TensorFlow to MXNet, you can do that. You can also log into the console, etc. So basically, this is the SageMaker Studio, how it looks like. You can create your folder and start working on it. Okay, so we will not, go through about all of this. But what we are going to do now is we'll quickly see a small problem which resonates whatever we have learned so far. Okay, so the problem that we are trying to solve is an image classification problem, and we are using Gurmukhi numerics. So that is this is a script from I think Punjab, and we are trying to identify these numbers. Okay, so this is if you are from Punjab, you might know what these are the numbers that we need to identify, whether this is 0, 1, or or whatever, right? So this is the problem that we have. So this is one of the problem that we used in one of our workshops, so just thought to pick that up. And we are going to use PyTorch for that. So if you're new to PyTorch, so PyTorch is nothing but a Python library for deep neural network functionality. It gives you a lot of power to calculate the derivatives and loss function, etc., etc. So it's very amazing. If you are getting started with deep learning, there are lots of other options available like TensorFlow and all of this, but I would strongly recommend to go for PyTorch. Okay, so the way that you would do is you should have first the training and validation data, that is the test data and validation data. And the data is I already downloaded in two different folders. One is training and one is validation. And in each of these folders, I have subfolders, and all the subfolders are named like with the digit number. So this 9 means all the images inside this contains 9. So if I show you in my laptop, all these 0 folder contains images of 0. Okay, so it's like that. All right, so now what we are going to do is we are importing Torch and Torch Vision. These are the libraries which comes under PyTorch, and other libraries are normal libraries like time and all of this. So it's nothing that fancy. So what we are going to do is our image is of 32 by 32 pixel, and we will change it to 28 by 28. We could have done it through 32 by 32 as well, but we'll just change the resolution because previously I worked on MNIST dataset, which is again another dataset for numbers, which like English numbers. So that's why I just thought to use the same resolution. And then we will have a couple of hidden layers, and we will use softmax, and then we will have some loss functions, which is nothing but the cross entropy we are using here, which you can think of it as a difference between the output and the actual class, but it has some logarithmic function around it. So this is the advantage of using PyTorch, right? So I have imported PyTorch, and I'm using the NN module of PyTorch. And here you can simply just mention what are the layers that you want. So I want a linear layer, that is the first layer, okay? And then I want a ReLU function, and then I want another linear layer, right? So this is how I do it. So I just created a small wrapper function. You don't have to use that, but since I had to do some experiments that what would fetch me a best prediction if I have 2 hidden layers or 3 or 4. That's why I just have a small wrapper function which takes the hidden layer sizes, and it will just read the length of that. Okay, but the idea is you define the layer and then you add ReLU. Then again you define the layer, then you add ReLU. This is exactly what we have seen in the presentation, right? You sum it all, do the dot product, and then you do activation function, and then ReLU, and then pass it on to the next layer. So if you have 2 layers, it would be like this. If you have 3 layers, I just added one more layer. Okay? And the fun thing to see here is, if you have noticed, the output of each layer becomes the input of the next layer. The output of first layer goes as an input of the second layer, right? So you have to be very mindful about the shape of the matrix, how it is flowing through the neural network. Okay, and that's how it whole thing works. And then at the end you have a softmax, a log softmax, which is nothing but a logarithmic function of softmax. We just added a log because computationally log is less computational, right? Because if you do a division, it's more compute intensive, but if you do a log of a division, then it becomes a subtraction, right? So log a by b becomes a log a minus log b. So that's the reason we use softmax, log softmax, and all of these are part of PyTorch module. Okay, you are not you don't have to write anything. And then since we have to experiment that, we have lots of loss functions. We are using NL loss, but you don't have to worry about that. So just think about it like The loss is nothing but the difference between the output and the actual class label, right? But there are different types of losses available, like cross entropy, smooth loss, mean square error loss, etc. And now this is the whole the actual function. How we are doing is how we are going to train, right? So we are going to load the data, and how we are going to load we will see in a moment. But basically we will take some set of images, okay, some set of images, not all. We will do it in batches. So we'll take some set of images, and those images are having three channels, so red, blue, RGB, basically red, blue, and green. But since this is a black and white image, all the channels contain the same information. Okay, so that's why what we are doing is we are taking a bunch of images, a batch of images, and we are just picking one of the channel. Okay, so here I picked the channel, third channel. It starts with the index 0. So you can have here you can have 0 or 1 or 2. Okay, if you write 3, it will fail because it doesn't have 4 channels. So since this is a grayscale image, I don't have to do any image processing on this, but I will just pick up one of the channels. So here I picked up the second channel, and the first colon is that signifies what is the size of the batch. So let's say if I pass 10 images at a time, so the size of this matrix would be shape would be 10, and it will have only one channel, and the size of the image is 28 by 28. Okay, so this is the whole thing. So 28 by 28 is nothing but 784. So we are just converting an image into a vector. So you can think of it, you can imagine that you have a matrix of 28 rows and 28 columns, but what you are doing here is you are just converting it into a single array of length 784, right? And then you have such arrays 10 times, because 10 means nothing but 10 different images. Okay, so now what we are doing is we are trying to start the training process. So before we start the training process, we are setting the derivatives to 0, because one thing that we have not discussed is how we update the weights, right? We know that we collect the loss and then we update the weights, but how we do that, we have not discussed, because that is beyond the scope for this session. But we use something called stochastic gradient descent. What basically we do is we take the derivative and we try to subtract that from the actual weight. Okay, and why we need a derivative? Because if you think about it, let's say, let me just show you here if I can show you. Yeah, if you have something like this, right? Let's say you have a function like this, and you are at this point. What is the minimum value that this point can have? Obviously, it is this point, right? But how we can know this? What is the exact x and y coordinate for this? How we can know this? One of the way that we can know this is if we take the derivative of this function, right? The slope becomes 0, right? For this at this point. So if you take a derivative of this function fx, right? You will, and if you make the derivative of this, right? If you make the derivative of this as 0, whatever the value that you will get, that will be your local minima or global minima. For this case, local and global are same. But if you have a function like this, then a local minima would be this, but the global minima would be this, right? So basically, you have to keep on doing partial derivation, differentiation to come to this point, right? And we don't have to do it of our own. That's what PyTorch can do. But before starting the training, you have to make sure that all the derivatives are set to 0. And then you call that model class which we have just created function, and then you calculate the loss, and then you do a back propagation. This is what loss.backward does. And we are not doing anything. Everything is done by PyTorch, right? So we are not doing anything for that matter. And then we are updating the weights. Now we have to, because the moment you do this, all the partial derivatives have been calculated by PyTorch, and now you have to just update the new weights and keep on iterating this loop. Okay, how many times? Depending on what is your preference, right? So for this problem, I guess we did it for 15 times. That's all, right? And then we are just doing some printing just to see that how the training loss is going with each iteration. And all these small wrapper function, we don't have to go over this. This is just how to, augment that, not augment, how to manage those images to print on this Jupyter notebook, which we'll see now. So now we are loading this data. We are using a transformer. This is again a method, a function within PyTorch, and we are just converting all the images into a tensor, right? Because our images are in the form of pictures, right? So we have to convert it into numeric numbers. So that is what in PyTorch we call it as tensor. I mean, in fact, in all the frameworks we call it as tensor, which is, you can think of it as a n-dimensional matrix or array. And we just give the folder name, and it automatically takes the image parent folder, and it automatically labels that image into that class. What do I mean by that is, the moment it will load this image, right? How it would know that this image contains 0? It will just read its parent directory, and it would know that this is an image with class label 0, because in the image there is nowhere I've written it's 0, right? And again, even if I had, then again it would have been another machine learning problem, deep learning problem, to extract text from that image, right? So that's how we load the data, and then we simply start the training. So here I'm saying, if you look at this, I've mentioned hidden sizes as 128, 32. That means in the first layer I want 128 neurons, and in the second layer I want 32 neurons. That's all, right? And output size is 10. That means you have 10 different numbers, right? 0 to 9. So that's why we have mentioned output size as 10. And learning rate is something like how you want to approach. So let's say in this example, let's say you find it, you are here and you want to reach here, right? And now one way you can do it is, you know that you have to go down. So drastically you can change it and you can come here, right? If there is no learning rate, you can come here. It might so happen that you come here, but actually you should have come a little bit slowly towards the downhill, right? And then you would eventually reach this point. So who controls this movement, right? That is nothing but your learning rate, right? So if you have a very high learning rate, you will jump like this. You will go from here, 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 and then you maybe at some point you will come here, right? But if you have a small learning rate, then you will eventually come like this gradually, and then you will end up at the very local or global minima. So that's about learning rate. Now, if you start the training, we use that fit method, which we have defined earlier. You will see that after every training, the loss decreases, right? And eventually, after 15 epochs, so epochs is nothing but how many times you have passed through all the data through the network. If you have 100 images, if I pass that 100 images 10 times through that neural network, then my epoch is 10. Okay, so epoch is again a fancy name, but it's basically the number of times you pass the whole data set, not a subset of your data set, okay? Whole data set through the neural network during the training time. And this is also not a magic number. You can train it through 15, 20, 30, whatever it is. And then if you do a prediction, you can see that whether it is predicting correct or not. So I'm just running it multiple times. I'm just reading it through the validation folder, because if you remember, we had two different folders. One is training, which we used, all the images in this training folder we used for training. And validation is, I have kept few images separate, which I thought to use only during the testing time. So all the images inside this folder were never seen by the neural network. Okay, so this is the best way to test. So if you see, the right-hand side graph is nothing but the output of that softmax function, which is just plotted in this small tiny graph. But this is actually the probability class. Right? So you see that this is the last neuron which got fired. Right? So that's how you can build things on AWS. And one nice thing about this SageMaker, whole of this SageMaker is, you can share this code to anyone, right? And the other thing is, you can change the kernel at any point in time. So let's say I go to new notebook, right? And I can change the kernel from here. See, I have not installed anything, PyTorch or TensorFlow, whatever, but I see all the kernels here. So you can pick any of the kernel and you can start working on it. Not only that, you can also see the number of CPUs and GPUs, right? So you can also change the number of CPUs and number of GPUs based on your comfort. You don't have to switch over, close the notebook and all of that. You can just select here and save and continue. Your code will run, into that system. Okay, and we have not used GPUs on this particular problem, but you can always use GPUs for your training. All right, so that is also possible. So you don't have to worry about using GPUs for your training. Yeah, so with that, I don't have anything else. I guess I can look into a few of the questions that you may have. Okay, okay, so you said that we strongly recommend PyTorch over TensorFlow. Yeah, so I recommend PyTorch over TensorFlow. It's not because it is better than TensorFlow or whatever whatever reason we see around. The reason is PyTorch is very Pythonic in nature, and PyTorch. In PyTorch, what you can do is you can use the higher level APIs to write a very abstract level code without need to know a lot of things inside what is happening. But also, if you are into research and you want to change few of the internal things, you can still do that with PyTorch. Whereas if you use TensorFlow, you have to switch between Keras and TensorFlow API, because Keras is now supported in TensorFlow version 2.0, which is kind of similar to PyTorch. But the learning curve is a little bit steep in TensorFlow, what I feel. And in PyTorch, only challenge that I feel that we might have is the way that we load the data, right? So the way that we loaded the data, that is not very friendly when you look at it, right? The way we loaded the data, it's not very friendly when you just see this. Other than that, once this is done, to build a neural network using TensorFlow, PyTorch is very easy. For that matter, Keras as well. But I would still, this is my personal favorite, and PyTorch has been doing a phenomenal job, in deep learning, in last 1 year or so. It came up in 2017, I guess. But yeah. Okay, so there is another question. For using library in SageMaker, do we need to install anything? No, you don't have to install. So let me show you. So here we have the Jupyter Notebook, right? Let me open this Jupyter Notebook, okay, which I already have. So I just clicked on Open Jupyter, and now what is happening is there is an instance there on the cloud. We don't know where it is, right? It's not in your VPC. It is there in somewhere on AWS cloud, but all your data is secure, right? It's not like anybody can go and open your data or look into that. And then now if you come to new, you'll see all those kernels. I have not installed anything. I've just created a Jupyter Notebook, right? And tomorrow, if PyTorch come up with a new version, I will automatically see here, right? So let's say I click on PyTorch 2.7, right? So I have a notebook now ready, up and running with PyTorch library. And if I have GPU in that system, I should be able to use my GPU as well. Okay, so this is how easy that you can use Jupyter Notebook in SageMaker. Okay, and any other questions? Okay, so if you have any other questions you may like to ask, I'm just scrolling it up. Uh, okay, so by the time I'll just go through a few of the questions. What you can do is, so feel free to reach out to any one of us, Rohini or myself, if you have any queries, or you want to, get started with machine learning or anything for that matter. We would love to hear from you. Okay, so reach out. And in the meantime, while I answer a few of the other questions, you can try to scan this, and you may win some credits. In case the credit code doesn't work, just ping me over LinkedIn. I will try to send you a new one. Okay, there are a few questions. What is significant of kernel in a training? Uh, Training the ML model, do different kernel have different error probability? I did not understand what kernel, what do you mean by kernel? If you are referring to, because kernel have a different meaning at different contexts, if you are meaning here, this is here we call it as kernel. All these kernels are nothing but different packages that you can use to write your code. TensorFlow is one of the framework, PyTorch is another framework, and all of this, right? So this is also called kernel. If you are referring to this, then different framework you can use to build your model. Which module you will use, it's up to you. You can play around, and not every module can do what other models can do or packages can do, but most of these can do everything. All right, I mean, whatever one kernel can do from this perspective. But if you are asking kernel from neural network perspective, which we have not discussed, but there is a significance in of kernels, kernel size in CNN. Like we use 3 by 3, but we do have 3 by 3, 5 by 5, 7 by 7, all are square matrices. But yeah, in those cases, your model will differ based on different kernels. So I'm not very sure which kernel you're referring to. Okay, so last question is, sir, in SageMaker, hyperparameter tuning is possible that we can automate. Yeah. Okay. Firstly, you should not call sir. Okay, it's very embarrassing. And we have our faculties as well. And honestly, I feel nervous the moment I hear sir. Okay, so we are not eligible for that, right? So yes. So for hyperparameter tuning, we have something called hyperparameter optimizer (HPO), where what you can do is in that. You can simply say that learning rate should be zero point 0.1, 0.2, 0.3, 0.4, and zero point 0.9. And you just save it in an array, and you just tell SageMaker, okay, run the model for all the possible combinations for this, and it will do that for of your own. So this is one way to optimize your hyperparameter. But in this case, you are only providing all the possible values for different hyperparameters. Okay. Now, there is another way where you don't even give this. Okay, so let's say you want SageMaker to do everything for you. In that case, it will pick. It has the ability to pick up different algorithms, and each algorithm with different hyperparameters, and it can give you. It can run parallelly 50 or hundreds of models, and it can give you the output of each model with its accuracy, and you can pick that. So that is there. Okay, so Vaibhav, yeah, in CNN context, right? Yeah. So in CNN context, the okay, if we Rohini, can we take 5 more minutes? I'm already, or if we have
Fine.
this one.
Actually, can you?
Okay.
I'm not sure if you can hear me. But it is fine if you want more time. We have more questions to answer, so we'll just have a Q&A section.
Okay,
Okay.
sure. Okay, thanks. Yeah. So what is the use of what is the difference of kernel? I guess I have that slide. Let me pull that. Okay, I guess this is this should be this is good enough to. Okay, so let's say in CNN, what happens is you have this image, right? So let's say this is 28 by 28, right? And thickness you can or depth you can forget about it, but let's say it's 3, right? 3 is for like 3 different channels. Let's consider that red, blue, RGB, basically red, blue, green, right? And what happens is you convolve over this image, right? And what do you mean by convolve? You take one filter or kernel, right? And that kernel size can be 3 by 3 or 5 by 5 or 7 by 7 or even 1 by 1. So typically, if you see all the standard networks, ResNet or GoogleNet and all of these, they have used different types of kernels. But what generally people use is 3 by 3. Okay, and because that fetched a very good amount of accuracy. Also 5 by 5 is a good one, but 3 by 3 is the most predominant. You will find most of the folks in the industry, they use 3 by 3. But what is the difference between different kernels that you use? If you see, the idea of CNN is basically when you go to this output side, right? You will keep on adding layers, right? You will keep on adding convolutional layers and all of that. But at the end, there is something called refractive field. Okay, so what is the refractive field means is how much information you have when you come to this last layer, right, about this whole image. So basically what we mean by this is, let's say you are at this layer, okay, at the output layer, and there may be hundreds of layer in the mid in the along the side, and in this particular neuron you want to figure out how much information this particular neuron contains of this whole image. Ideally you want this neuron to have the full visibility of this whole image, right? All these neuron, let's say you have hundreds of like this neuron at the last output layer, you want all these to have a full visibility of this image, and maybe different neuron will have different feature extractor. Let's say this neuron will find out whether there is a dog or not in that image, okay, and this neuron will find out whether there is a human in that image or not, right? You can think of this all as neuron. Now how this will differ with respect to your kernel size, if you use 3 by 3 kernel size, what happens is this will go over on top of this image of 3 by 3 pixels, okay, and then it will do a dot product of this this 3 by 3 kernel. You can just forget about all these three channels, okay, because if these three here in the kernel also should have the same number of channels. So just assume that depth is 1 and you just have this green kernel which is 3 by 3, that's all, okay. Now what happens is, let's say you put this green one on this particular place, right? You actually start from very top, and then you keep on moving this side, and once this is done, then you come down and then you keep on going in this direction. This is how you go, right? So let me just clear this to clarify this. So when you do 3 by 3 convolution, after a multiplication of all these 3 by 3 metrics, right, you come up with one particular pixel, or this is actually the result of this multiplication, right? Now if the refractive field of this is actually 3 by 3, that means this particular pixel or whatever value, because this will have a numeric value, right? Whatever value this will have, and if someone asks, okay, what information this value covers, we can say that this has an information of this particular block of the image, not this image, not this part of the image and all of that. Whereas if you take a 5 by 5 kernel, it will have a bigger image coverage, right? So you might say that okay, why don't we just use a very big size kernel which will have the idea about the whole image, but that in that way you cannot identify features, right? So what we want is, we want to use small kernel size but in lot of different types of kernels. And when we say kernels, these kernels are nothing but a 3 by 3 matrix. So this, I think I have an image here, let me these kernels are nothing but 3 by 3 matrix. Okay, here it is. I don't have it, but basically, if you consider this is a 3 by 3 matrix, and all of these have some number, 0.1. It's ideally between 0 to 1. And what we do is, when we go to this layer, right, we just do a multiplication of two matrices. It's a matrix multiplication, right? So with this matrix to the number that we have in this image, and then we add a ReLU. So after this, we again add ReLU, and then we come up with this new layer, right? So the bigger the size of the kernel, the bigger the view of the image that kernel will have. But what we typically do is, we use 3 by 3, and we use different types of kernel. One kernel to detect, let's say, edges, one kernel to detect the patterns, and all of this. Yeah, I mean, I'm sorry for this elaborated answer. Yeah. One last question. FastAI is built on top of PyTorch. Is it? Yeah, you can use that. So those things are all wrapped around, PyTorch. So if you, basically, you can pick up anything of your choice. All that matters is you understand the concepts, and switching from one model to another model, it's not that daunting. But yeah, PyTorch and FastAI, these two are predominantly people go with these two because these are very Python friendly. Yeah. All right. So yeah, so that's all we have, and I hope that you
I have more questions, so I'll just answer
yeah.
those questions. I mean, please be on the stream because you may want to answer some of these questions as well. So first of all, the example that I gave, right, that was years ago. If something like credentials, access key, secret key are by mistake posted by our customers on GitHub or somewhere else, AWS promptly actually temporarily disables these credentials and sends an email to the account owner, right? That something like this seems fishy. You have done this. Please fix this, and we please fix this, and we will enable those credentials back. And a customer should. So, as a best practice, you shouldn't post them. Even if you do, there are some mechanisms from AWS side that will take care of, and from the customer side also, like customer should go ahead and change the passwords, like how you would do generally for your any other accounts, right? You just go ahead and change the passwords and rotate them so that anyone who has access to the old password will not work anymore, right? A lot of questions came around. I think Suman, you did answer those questions around data centers and cloud computing. So the major difference between a data center and cloud computing, I think that was my first slide, is cloud computing will give you a lot more advantages, as in you can access it over the internet. You can get access. It's like more towards the software defined data center where you can access it over the internet using certain APIs. And I think there's a comment for you, Suman, in the chat section. But so there are a lot of things that a cloud will give beyond a data center, right? So in the end, it's just a data center with more hypervisor and more softwares and managed services on it that are provided to the end customer. So when you, as a recipient of a public cloud, for you it will be pay as you go kind of an environment. So that's about cloud. There was another question about, I think this you answered. Yes, you can use any authenticator tool for MFA. There are few listed. As I mentioned, there is Authy, there is Google Authenticator, which are like very common, right? So you can use those kind of authenticators. If you want an exact list, I think that there should be one in one of the FAQs. I can send it across after this. The next question was, can you elaborate on the SLA policy that is offered by AWS? Interesting question. Not all AWS services offer SLA. So not no, not every service will have an SLA. Most of the older services like EC2, Route 53 have SLAs defined, but not every service will have an SLA because most of these things, the HA has to be worked by a customer. While managed services will give the HA, do you want to enable it or not for some of the services is your choice, right? So that way, if you have to look from an SLA perspective, only few services have SLAs actually defined. Do you have anything to add, Suman, there before I move to the next question?
No, that's perfectly fine. Yeah.
Uh, I did answer the question in the chat section. What is the need for Fargate if we have EC2? As I mentioned, like a lot of customers don't want to manage EC2. They don't want to manage auto scaling of those EC2 servers. They don't want to worry about patch management or security of those virtual machines. They want to take care of the core. They want to take care about the container, and they want to ensure that they only work on that part of the application. So that's why, to cater to that range of our customers who want a more opinionated kind of a service where they don't want to manage a lot of things, there are services like Fargate. um, Suman, just stop me if you want to add anything to the questions. Uh, and last question I think I got was, can you tell us about difference between global accelerators and CDNs, right? So think of CDNs where CDN can, they both use the same global edge network, right? The global network of edge locations that AWS has. But from a CDN perspective, CDN will help you improve, performance for your cache content and like static content like images, HTML files, or videos or something like that. And it will also help you improve the performance of dynamic content. So if you have any APIs in the backend or you have any dynamic site to be delivered, it will help you with that. Global Accelerator actually improves performance on the TCP or UDP side. So, for example, anything that is non HTTP, Global Accelerators will be a best fit for that. So, if you have, for example, anything with IoT devices, right? You have IoT devices talking over MQTT as a protocol. Global Accelerator will be a good fit in this case. While both use the same backend, the purpose of these services is different. I hope that answers the question. And is there any more questions that we have before we move on to the next section? I don't see any more questions. So what I'll do is I'll add, I'll just change the layout. And I've added Paramjeet and Saurav to the stream. So over to you, Param.
Thank you, Rohini ma'am. I hope you all had a great learning experience. With that, I'd like to thank Rohini ma'am, Suman sir, Avata ma'am, and all the participants for coming out here today. We look forward for more such interactions with Rohini ma'am and Suman sir. And for more such exclusive and knowledgeable events, don't forget to register yourselves with CSA in the upcoming registrations drive. With our recent collaboration with Cloud Security Alliance Uttarakhand branch, we have many events, workshops, and other benefits lined up exclusively for our member family. Saurabh will now brief you about the attendance form and the quiz. Do not forget to fill in the attendance form for getting your certificates. And I would suggest that you should, participate in the quiz so as to win the free and Nvidia the thing courses. So over to you, Saurabh now.
Thank you, sir. So now moving to the attendance session, I am sharing a link. So everyone just fill that link for their attendance. So let me just share the link. Yeah. So the attendance is going to be through your this form and also the survey link, which we are already sent. We are sending it again in the chat. So just complete both the forms, like Google form and the survey. And for NVIDIA courses, we are going to have a quiz. So let me share the screen for the quiz. So let me host the quiz.
By the time Saurabh is hosting the quiz, you all can fill in the attendance form and the survey form as well.
So please open this link that is shared.
I'm repeating the instructions again. Please fill the survey form, the attendance form, and then access the quiz.
After opening that link, we you have to enter the pin that is sent. So please enter the pin.
You can see the pin on your screens and in the chat as well.
So I'm just waiting to add. More people are adding for the quiz. So let's wait for 2 minutes so that everyone can join.
Komal Shimar, there's not a certificate link, there's a form link, attendance form link, which you have to fill for availing the certificate. Once you fill the attendance form, we would check it with our database and we would send you the certificate in a week or so. And after that, you can go on and access the quiz and complete it.
Yes, ma'am.
All the links are in the chat itself. You can check the chat and get the quiz link,
So
the attendance
I
form
think
link,
we have
and the survey link.
enough number of participants for the quiz. So I think we can start with the quiz now. So for the quiz, you have to see the question on my screen, and you just have options on your screen. So you have to see the question at my screen, and then you have to answer at your phone or laptop with which you are logged in. So let's get started. So what's the first question? So I think 11. Yeah, this is the answer that we get. And now moving to the next question. So please fill the answer in 20 seconds. Like you have only 20 seconds to answer the question. And the answer for the first question is Hadoop, as it is a cloud computing platform. We all know that, I think. Yeah. So yeah, this is the result for the first section. Yeah. Now moving to the second section. Yeah, second question. So the answer for this question is workload, which are the fundamental unit of virtualized client for IIS deployment. So it's a workload. Yeah. So yeah, this is the answer. Now, yes, stack is changing. So I think we can wait for more questions. Yeah. So next question. Yeah. So I think this section is already covered by Rohini ma'am. So yeah, lots of people are answered it correctly. So yeah, it's CloudFront. Yeah, Amazon CloudFront. And moving to the next question. So the answer is second one, and I think most of you got it wrong. So let's move to the next question. Now it's the fifth question. Yeah, this section is also covered by Rohini ma'am. Yeah, like different categories of instances. So it's a spot instance. The answer is spot instance. Yeah, so the answer is availability. Yeah, Amazon S3 is highly available. This is the wrong statement. Like we have different section for that. We have a glaciers and all. So yeah, this is the answer. Yeah, so most of you got it right. It's high CPU instance. So let's move to the next question. Yeah, basically CloudFront is a geocaching because yeah, it's already covered by Rohini ma'am. So basically, it's for caching and for specific, it's a geocaching. Yeah. So let's move to the next question. So let's move to the next question. Yeah, so it's elastic block storage for storing machine images. Yeah. Yeah, it's Amazon SageMaker. So Suman sir already covered, like we used SageMaker for building, training, and deploying our machine learning model. So let's move to the next question. So it's Amazon Poly, yeah, to convert text into a speech. So let's move to the next question. Yeah, it's Boto 3. Yeah. So let's move to the next question. Yeah, so it's cloud. Yeah. So let's move to the next question. So it's the last question. Yeah, so like we have computing. Yeah, is a as a utility. Yeah, this is what the whole agenda of studying cloud computing, I think. Yeah. So it's a result time. Yeah. So we have the result. Yeah. So, guys, before leaving the session, uh, please fill the form. Please fill the form, both the survey link and the attendance form for getting certificate from AWS Educate itself. So thank you for joining in. Yeah, thank you very much. We are hoping to see you in the
Yeah,
next session.
congratulate. Yeah, I congratulate the winners. And as Saurabh mentioned, do fill the survey form and the attendance form for getting the certificate. We will send the certificates on your email ID, registered email IDs within a week. You can reach out to us after the session ends for any queries related to anything, for joining in CSA, for other such events, and becoming a part of the CSA family. Thank you all.